Hello, hello. Oh, I see we already have people here. That's cool. Hello, everybody. So, last night was very successful, and we want to build on that momentum. So let's go. The first part of this is we need to make these stringify directives not so wonky. Specifically, here, when we actually do the stringification, we have this weird thing here where if it's a string already that we're stringifying, we kind of just stick the value in. If it's not, we rely on the current code gen, like append node as string stuff. You can ignore this part. This is part of our to-do cleanup. We're doing this in a really lazy, hacky way right now, which will change. But the part I do want to change is basically all the logic here that's choosing how these things are stringified is not good. Because right now, let me comment out all this stuff so we can get to a... Oop, don't know how that got in there. Get to a clean output. If we run this, what did I do? 15. Again, something else got in there. Weird. Okay, not putting anything to the screen. If I just print the file name. So file name here is going to resolve to a string literal containing the file name. So we should just see the file name as a string. Great. Right now, if we stringify this, I was thinking about this. What happens is we still just get the string back, which means stringifying a string is idempotent, however you say that. I can basically do this as many times as I want. Oh, well, that's actually a different reason I can't do that, but theoretically, you could do that as many times as you wanted, and it wouldn't do anything different. But I think what actually needs to happen here is if you stringify a string, I think if your string looks like this, I think stringifying it should give you a string. So say this is your string. I think it should give you this. So every time you stringify, it just gives you whatever you had in quotes. So if the thing you had was already a string, it should give it back to you, because you want stringification to be what it looks like in code, basically, as a string. And a string in code has quotes around it. So let's set up a case here where we have, well, let's just keep what we had here. We'll have file name, we'll have stringify the file name, and we'll have stringify, like, how about this whole thing? Without the semicolon. Okay, I don't know if we can actually do that, so we'll punt on that for now, but let's at least do this. So forget this. We will always just do this part, and I think this will cause us to not compile. Yeah, because now we are expanding into we are now expanding into this because we're not escaping the string. So we're expanding into this weird line here where these are the inner two quotes are the quotes that came from the fact that it's a string, and these outer two quotes are the stringification happening. So I think what we want to do is just escape any quotes that are in this final string And I think we have a... do we have like an insert character, append character? We might not. So... That's okay. What we can do is we actually don't have to allocate this string here. What we can do right, here's what we'll do. We will make this string builder, and man, the fact that I'm using the string builder is making this a lot more complicated than it needs to be. I kind of want to jump ahead and do the to-do really quick. At least one of them, which is to pull this function apart. Right now this function takes a string builder and does what we're doing here. It turns it into a string using a string builder and appends it to an existing builder. Really what this should do, I need a separate function that just gives you a string for the node. Doesn't append it to anything. So then you can use it wherever you want. This can still have the builder and do all the stuff, but to actually get the string, I don't think we want to be doing that. So let's start there. That to do is still relevant, but we're going to say, actually, this is going to be on our new function though. So, actually, let's just modify this one instead. So, get node as string. We're going to say, do we have in metagen, do we have a scratch space? I don't know if we do. We might want scratch space here. No, we don't. Because currently all of these things are expecting to append to a string builder. Let's think about this. Where do we init the parser? Let's say the parser itself has some scratch space in it in its arena, because the parser should have an arena in it already. Scratch arena. Or scratch space, I guess. So when we initialize the parser, which we do, we do it inside of here. Lex parse and run metaprograms. So the first thing we should do with this parser, wait. Oh, okay, never mind. We don't have to do that, actually. Because we're passing it this input arena and the output arena. So, actually, we could just pass it some scratch space ourselves. Which I think we'll do. Scratch arena. I think we'll do that. So when we go to main here, arena, we will say we have scratch arena size. We'll just give you a megabyte of scratch size. It's just going to be for doing these kind of string operations and stuff, so it's fine. Scratch arena. So arena. Here we initialize them. We're going to do the same thing, but for scratch. Great. We're going to pass it in the scratch arena and clean it up. Okay. So now when we come in here, we can use this scratch arena. We can say lex parse and run metaprograms. We're going to pass it the scratch arena. Lex parse and run. Okay, so the lexer doesn't need it. The parser is what needs it. So we will stick this on the parser, but it's just going to be a pointer to it. So scratch space. So we'll say the parser's scratch space is the scratch arena we passed in. And what we're going to do is every time we run the metaprogram, we will reset the scratch arena. So do we just have a reset function? Yes. So run metaprograms. We call run internal, I think. Yeah. So every time we run internal, we are going to reset the scratch arena. Reset arena parser, global parser, scratch space. Okay, let's make sure that didn't break anything, which it did. Whoa, in append node to body. Oh, append node as string no longer exists, right? We're in the middle of doing that. So let's briefly put that back the way it was to make sure we didn't break anything. Oh, I changed it to get node as string. Let's change this back really quick. Great, we're still working. Let me quickly disable this to make sure for real that we're working, which we are. Great, now we have the scratch arena to work with. And it gets reset every time we run metaprogram, so we don't have to care what we do with it. So, append node as string here. This is going to be get node as string. We're not going to pass it a builder. We're going to get the node. We don't need the file path, the right lines. We don't need any of this stuff. We just want the code as a string. And actually, let's keep this around because we're going to need this for later. Okay. This function is gnarly, dude. Okay. Get node as string. Doesn't need a builder. It doesn't need anything but the node is all it needs. So, don't care about this or this. Switch on the node's type. Do we already use builder here? We do. So what's nice about this is we can just say string metagen string builder. Builder is create string builder. Is that what it's called? Why am I not getting autocomplete? That is what it's called. So we're going to pass it the global parser scratch space. So we have a new builder and result builder, and we'll say, just so we don't have to modify the rest of this function, pointer to it will be builder. Okay. So this should do everything that it's already doing, right? I don't think this takes... Well, we use all these append functions here, which... All these append functions assume that we're appending to code paths. Which is not great. I think, can we just omit those lines? I think... No, because we want... Those should all live. Oh man, am I going to be able to split these up like this? This is going to be tricky, actually. Because sometimes we want to break these things up with line numbers, like in between arguments and stuff. But if we just want the node as a string, we never, ever, ever want to care about that. So I almost feel like this needs to be... Oh man, this is... This is kind of gross. Ideally, okay, let's go back a little bit here. This is going to not be quite as nice as I was hoping. So let's open up the other one side by side. So here. So we want this. These intrinsically can't be split up, because this will give you the whole node as a single string with no file, line directives, anything like that. This is appending that to a final output as like code gen, where we do need that stuff. And this already can do that because we're using this function for our chunks, actually. We're using it for this. So, okay, maybe this doesn't need as much modifying as I thought. So, okay, hold on here. Node as string. Let's go back here. So, okay. Let's still pass it these things. Okay. We'll still do we will still do this stuff, but we will do our string builder thing here. Global parser, scratch space. Okay. So we still do all this stuff. We append everything we do, right? And then at the end, all we do is we return build string builder. And what this needs to return is a dynamic string. Right? So, so we actually don't need this. Well, actually we actually can keep this and just do this. Append string builder get node as string node file path right lines, synthetic line numbers, right? We can just do that. Let's create prototype for this one without the builder. So I think with this, I feel like we are... This function's still really gnarly. It's doing a lot of different things. So if I just build this, I think we should still work. Oh. File path, wait. Oh, because this needs to return a dynamic string. Nope. So I'm guessing there's something about set synthetic line numbers. That's fine. Maybe append? What is that doing? That's fine. You know what, let's just, instead of guessing, let's just step through it, see what happens. Where is code gen? Build string, oh. Build string does not protect against nothing being built. Although why would nothing be being built? If builder, what is it? Strings. Okay, that's not actually the problem. So build string, does it not actually? No, it does. It already does that. That's fine. We need to look at build string, and let's just see where we were. Get node at string. What is the builder? Strings value. So that's it. It's just getting value. Then it went into here. Current is builder strings. Current is nothing. Oh. We're running out of space. We can't just, the scratch space is not just for, okay. I completely forgot about that. The scratch space should be reset every time we do this. Whenever we do this, we're going to reset the scratch space. The whole point is that we can use it in places like this and just make sure outside of here we no longer care about its contents. So we can safely do this and not care. So we reset it, we use it, we build the string, and return it to the caller. They can do whatever they want with it, right? And the next time we come through here, we will free it because we will just override it. We don't care. Okay. So now we might be running out of room. Where are we running out of room? Pause. What is the node we're trying to write initially? Let's see here. Builder, arena, size is, wait. What? How are we out of... How are we out of space? There isn't enough room. Dynamic string. No, we're in string builder. We're a string builder. String builder. Isn't enough room. What? Try to append string, but there isn't enough room. Where are we doing that at? Enough room. Oh, we're in dynamic string. Okay. Okay, hold on. Hold on. Append string. Oh, in the string there's not enough room. Well, what are we trying... Wait, what are we trying to append to a string for? Build string. Find out how big the resulting string should be. Oh, yeah. Wait, how are we failing this? Hold on. Here's our builder. Our string is value. It's just 3 strings, right? One is value. One is... Well, I don't know what this is, but it's long. Although, wait, size 15. This is weird. Source length. This is a weird string. I don't know what this is. Where did this come from? Length 101, but the size is 15. Excuse you? Value. Let's look at the decal ref that we're looking at here. Where are we? Value. The parameter. Line number 2. Alright, what is this thing's parent? Where are we? We're in a function template called... We're in absolute value. So let's go look at that. Here we are. We're in here. And what is our line number? We are trying to do line 6. So we're here. We're at one of these, right? One of these values is it's freaking out trying to return it as a string. Parent is a binary operator whose parent is a ternary operator. So we're here. We're at this binary operator. Value is less than 0. And it is returning some weird stuff. Why? I don't know. So let's see. Line number 6. And our builder right now, we said, has 3 strings in it. It has value. The next one is weird. And the final one is just a closing quote. Don't know why. Something's weird here. Hold on. Let's go back to... So we append string using this. Let's do this. Let's do this and just see what things we get here. And if we, whenever we break, let's see what we got. Okay, we break like immediately. The first time we try to call this function, we break. With value quote. That's not great. But at least it gives us a place to step through that is consistent. Where's CodeGen? Oh, we're in CodeGen. Great. Append node as string. Let's go right here. So, very first time, string is this, which is actually correct. Oh, we did see that, didn't we? We did. Okay, yeah, we did see that up there. I missed that entirely. So we see that, okay. We append the string to what builder is this? Nothing. Where did we come from? Run stringifies. Okay. That's fine. Next time, we came from append node to body. We're generating a function template right now. And the function template we're generating from is absolute value. Great, we knew that. Maybe it's the 0 that breaks it. That's actually not a bad point. I had a previous issue come up where it was interpreting 0 as a pointer, not an int, and it was breaking all sorts of things. Welcome, by the way. So, this next time when we run getNode as string, the string comes back as... Okay. That... Oh, we haven't... Wait, what? Okay, hold on. Something weird is happening there. We skipped this one. Let's step into this. So the node we're trying to get is this whole return statement, right? So actually, let's also print the node out so we can see when we do this. Let's print AST of the node just so we can see it. There, that'll help, I think. So step. This one we don't care about because this is just the string, right? We know that one worked. Next time through, we want the return statement. But the return statement is this whole line, right? We want the return statement, which is return this ternary operator, which is a binary operator, a negation operator, and value, right? So we want this whole thing as a string, right? Return the ternary operator, which is a binary operator, negation, and identifier. So let's step in and see what's happening. We reset our arena. Oh, duh. This is stomping over our... Because this function can call itself, obviously. This scratch space, we can't step over it here. This is not the place to step over this. We can't stomp out that data until... so that's fine. CodeGen. This is not where we do this. Where is a good place to do that? Yeah, that I did not think that part through well enough. So we need to because right now if we do it every time we run a metaprogram, that is just not enough scratch space. Like we run out of space. So although why are we crashing? That shouldn't actually crash. Did I actually verify that that's what's happening? We're running out of space. Let's close these. Builder arena. So this one's definitely not out of space, but the string is not valid. Do we have... Here, Scratch Arena. See, Scratch Arena is definitely nowhere near full. So maybe I'm misunderstanding this problem, actually. So let's... right here, we are... appending to the body. And what node are we appending? We're appending the return statement. So we append node as string to this function decals string builder. Go in there. Get node as string. Right, still we do it. Go in here. We see that it is a return statement, so we append the string return. Maybe append a new line if we need to, and that's for the code gen stuff. So we can, like here. Sometimes I forget the logic as to why, but sometimes we append a new line and mark it. Other times we don't. I don't remember the logic for that, but we do that. So then, if there are valid children in the return statement, we then call this again and append it for the children. So we do that. We get that node. So now, instead of a return statement, it should be this ternary, which it is. Do it again. The binary. Do it again. The decal ref, which is value. And this is part of the binary, right? Parent is the binary, right? This decal ref is here. So we're talking about this one. Then we call getNode as string on that. And the builder here should have one string called value. 5. Good. We call build string on it. And we fail. We fail on this simple case of value. It's just a 5 length string. Why is that failing? If we go to the site, builder strings while current. So the builder here, strings, is this. But current is invalid. Why? We can see it's valid right there. Current, but current is not. Why is current not? I mean, these are clearly not the same pointer. In fact, it's moved up by... Here's 5F, this is 6F. I think the rest are the same. That's bizarre. Let's... Okay. Let's break here while builder arena used is 110. See if we can't break at this time. Right, so results is value. Oh wait, no, hold on. The string is value, right? That's what we want. So builder strings is definitely... Although wait, that's next, right? This is saying next is... Hold on a sec. If not builder strings. So what is... Can I do this in here? I can. Okay. So the current node should be this thing. So if I do builder strings 0, it's this thing. It's value. Which it is. And so current string size and length, they're set. That worked. Current is current next, which should be... Oh. Oh, that's why. When we reset the arena, we're just resetting the used part. We're not zeroing out the memory. And all of this assumes that the memory is zeroed out. That's why. So, we're gonna say 0 memory. But by default we won't. But if we do want to, we can just do, well, not memset. We don't use that stuff here. We say well, we can just say, yeah, that's fine. We can just say, do we have like a no, that's fine. So we can just say we'll say from the beginning, which is position is arena base. Although, do we really want... I'm trying to think. Why do we have to... Now that I think about it, hold on, before we do this, before we go down this road of clearing out memory, where were we just now? We were in... So... Right, when we create a node to append string. Right, we push it on to the arena. Here we're just assuming that the arena is empty, which is a bad assumption. Can we just do that? Yes. So now we don't crash. Now we're saying we're running out of space. Right. Okay. So that makes more sense now. We were not assuming the arena was empty because we're using this scratch space over and over. I don't love this having to care about that though. Because the assumption is that when you are appending to an arena, that it's going to be 0 by default. Like, you're expecting to get a valid thing back, so I don't want to start introducing that everywhere. So, let's go back to this here. Because I guess for scratch space, sometimes you really do want it zeroed out. Because sometimes you don't care. You're just writing stuff and using the chunk you wrote. But... And that won't care what's there already. The reason this cares what's there already is because... Well, hold on. Yeah, we should be clearing this. We should be able to clear it if we want to. So let's say... let's loop over... position is arena base. Position is less than, so we can say can I just do this? This. I think I can just do that. Let's just zero out the whole thing. And then in code gen here, reset arena. Here we definitely want to zero it out. We probably still run S space though. Yes. So now we can at least see where we're running out of space. So memory arena. Push size here. So where do we? Oh wait. I can't break on the assert. This is goofy. This. That's got to come before the assert though. I need to have a better utility for that, but it's fine. Wait, I have to... There we go. Okay, finally. Let's break here. Yes, okay. So where did we come from? We are in... We're reading in the source file. Wait, already? What? Wait a minute. Size in bytes. Oh, I changed the wrong thing. I am batting 1,000 today. I was like, that didn't make any sense. There we go. Okay. Here we go. Now this makes sense. So where are we? We are in a multi-layered get node as string call. Because the initial node that we're working on is a function, and what function is this? Copy string. So the compound statement, the if-def, the compound statement. So let's actually look at this. Copy string. Wait, we are in dynamic string here, copy string. Right, we are in one of these. Oh, okay, we have an assert in here which gets expanded. Where is that expanded at? This assert gets expanded to a bunch of stuff here, even though that's not that long, so that should not actually be a problem. Because all the way, so if def, right, so that's this. It's a compound statement, if def, the if def, another compound statement, if, so that's here, compound statement. So really, we are already out of space here. I'm trying to think why that makes any sense, because the string here, oh, that's huge. Oh, this is when we write out the final file. This is when we write out the very, very final file. Right, we don't want to use the scratch space. We only want to use the scratch space when we just want the string. If we're actually doing the final output, this is where it's going to get gross. This is the problem. So here, if we're just getting a single node as a string so we can print it out or do whatever we want to do with it, great. That's no problem. We're doing that no problem whatsoever. But this is also what builds this whole thing. And that doesn't need to be hitting the scratch space at all. That just needs to append to the final builder. So let's say you can pass it a builder if you want. And if you do, we'll say this is the optional builder. So this can stay here. This is the optional builder. If not builder, is this right? So if they don't pass us in a builder, we need to make one. But we don't want to lose it, so that's fine. This is like basically free for us, so that's fine. So then get node as string here. We want to just use the builder that we have. Everywhere else, like, right, we're not using that yet anywhere else, so that's fine. This should go back to working as it did before. Missing closing paren in expression. Did I change this? No. Wait. The closing paren, it got absolute value. Hold on, what is it? In the return statement. We never use absolute value in a return statement. Okay. I'm going to undo what we just did here. I don't like the added complication here. There needs to be a better way to solve this problem. So we can keep the scratch arena in there for now because I do like having it. This can still be append node as string. Okay, and then we go back here. Stop doing this. Okay, we're working again. So I need two versions of this. One that just sticks it in the scratch space and gives you the string, like it builds it and gives it to you. And one, the problem is it also goes through all these other helper functions. This is a problem where I designed this at a time where I didn't think I'd be repurposing it for something else. This is not great. Hacky builder. So let's go back here. So So for one, this could be the scratch arena, right? That makes us feel a little bit less bad, right? So we build up this string in the scratch space and then just copy it over to the actual arena. So this, how we doing, everybody? See, we want to rewrite this to give you a string. Doing that is just so not easy. Okay. What if we do this? We will leave append node as string as is. But, and actually we can put this above here because it doesn't actually matter. We are for declaring it. What if we flip the problem on its head and get node as string? Does in fact take the node, and that's it. We will create a string builder here. And it'll use the global parser's scratch space. And we will do append node as string. We'll pass it this one. So we're basically doing what we're doing over here, just doing it in the scratch space over here whenever we're requested, and we can say no to this, no to this, and no to this, and just return this. Nope. Okay. So this hacky thing I'm doing over here, I'm still technically doing it, but we're doing it in the scratch space. So we can say the string is get node as string. What were we doing here? The child is what we wanted here. Oh, I need to remove the for declaration of this. Get node as string. Don't need this anymore. So behind the scenes, this is still using a builder, but it's fine. We can piggyback off of that one function and just don't print out any of the metadata. And we're doing it in the scratch space, so it's fine. And then we give it to the node. Okay, I still have to forward declare that because C and C++. No, where do we do that at? Util? Yes. That's fine, I guess. Good sign, we still compile. So, now, let's go back here, and let's say, when we run stringifies, so this is still working, right? But if I write the string to the screen up front, wait, did that not? Why did that not print out? Oh, because I'm not running a stringify. Duh. Let's stringify the line number. There we go. So we're seeing that both in the metaprogram and in our actual program. So that's great. Now, if this is a string though, if we want to stringify a string, that's the whole reason we're doing this. We want to see this in the code, but that means we have to escape the quotes. If you're going to stringify a string, you expect to see this whole thing as a string. So we're back to where we were, but now we have this string on its own in scratch space, so we can do whatever we want with it. Such as this thing that we allocate, instead of allocating a string, we're going to allocate string dot size, or length, plus 2, because we're going to add 2 escape characters to it. Wait a minute. That's actually, no, we need to find out this. Num quotes equals, and I think we have a helper for this. Num instances of character in string, and the character is this. Okay, so we want this to be num quotes and pad the size. So now we can just copy the string. So for we're doing this thing's size. Okay. The character is this thing data at index. If character is a quote, we will insert this thing. We will append a, or wait, what is, how does this work? Append character. Are we doing it by length? Yes. So this thing, we will append a escape character, and no matter what after that, we will always append string index. I think. Not quite. Let's see what that generated though. Okay. I don't know what these are. That's weird. Do I have that in the code there? What is that? Oh, I do have that in there. Okay. Weird. Okay. So we didn't escape them. There is this weird thing. Oh, that's our extra space. Right? Those are 2 extra spaces for the escape characters, but we wanted that. And we didn't get it. You don't have to escape that, do you? No, that's not how that works. No. That's not how that works. Let's write the character. Can I do this? Is that valid? Is that allowed? No. Is that allowed? So why? No, that should actually work. We're not getting anything from this. Oh! I should pay attention. Of course, this is not where that's coming from. This is coming from the string. Duh. And this is the character. What is happening tonight? Things be crazy. Hey, look at that! It works now! That's the stringification of the string hello world. Right? If you're going to stringify a string, you get the string back. If you stringify the function platform right error length, you get platform right error length. Look at that! It worked. That's great. If we do the file name, we get that. Can we stringify the file name is the question. Ah. Where'd we go? What did I just do? Oh, I moved this to the... Oopsie. That goes there. Okay. Can we stringify the file name is the question. We can! Great! That's awesome. That's what we want to do. Can we stringify multiple times now? This totally flipped out before. No, that's a parsing question, so we don't do that yet. In fact, we can put a multiple string nested stringifies fail to parse. So that's awesome. So now let's put this in here. Ah. Okay. Oop. So now let's try our snippet again. So we have a snippet here that takes an argument, and we call stringify on the argument and then print it out. And in fact, why don't we just remove this extra step? So what should happen here is whatever you pass to this snippet should get expanded here and then stringified. So I should be able to say stringify hello world. Right? So I'm passing it hello world, which is a string. It should stringify it. We should see it. Bro. I can also stringify this global pointer to the temp arena. There we go. I should be able to stringify a whole block of code. I think. This is actually dangerous. I don't know if this will work. No. That's just not a thing. But, so, we wanted to write an assert that no longer relies on macros, which we couldn't do because we couldn't stringify certain things. So, this assert message, right? We have to do some goofiness here, where we get the line number, we do an int to C string, we do all this weird stuff. We shouldn't have to do this anymore. Forget this. We can write output, stringify file name. We don't have to stringify, we have the file name now. We can stringify the line number. Yeah? Does this just work now? We won't hit any asserts, but we need to hit an assert, like, we were hitting them all over the place today. Let's make the memory arena, like, 2 bytes, and try to push... Well, let's just make it 2 bytes. That'll surely trigger something, yeah? Wait, do we not have... Oh, you don't have to... Duh. Bytes are just bytes. Okay, so now if we try to print something that is even remotely bigger than that, we will definitely hit... wait. No, we need to do one of our structs, I think. We need to hit the temp the temp arena. Really? Wait, what? Oh, it's a ring buffer for one, so this is actually not ever going to be a problem. But wait, how is that working? Ring. Okay, this logic's gonna have to change. I wrote this way early on before I was really knowing where the platform was gonna go. This is actually not even how this should work at all. This is saying that we can't run out of space in a ring buffer, but we actually can easily overflow it. Like, absolutely. That is not the right check at all. So, turn that off for now. There we go. And there we go. So this right here is platform write error. Wait a minute. And we early returns. Okay, we return 0. That's still not hitting an assert. Damn it. In fact, I'm gonna put it to do here for... How about I just do an assert myself? Do this implement real ring buffer support from the OS regardless of that. Our current ring buffer isn't even correct. Okay. So that's fine. Let's just assert ourselves. Okay, let's just call an assert message. B32 value is true. So we assert value. We say we hit an assert. We don't hit it. Change this to false. we hit an assert. There we go. So this line number, this file name, is no longer coming from the C compiler. It's coming from our code gen, right? It's coming from this, and we're stringifying the line number. This is all coming from us now, no longer coming from the compiler. That is fantastic. That's what I wanted to do. So if we go to, let's look for somewhere in here, I have a to-do for, okay, so that's awesome. What this means is, now that we are fully independent of, oh, that's another thing that I wanted to make sure. So this assert is on line 38, which it is. If this was just a function call, this this line number here, if this was just a function I was calling, would actually report line 8, right? Because I'm calling out to a function. But because it's a snippet, just like macros, it's inserting into our AST at this point, we're getting the right line number, which is what we wanted, right? We're getting line 38 in this other file. So that's fantastic. One thing though, is I want these asserts to be print-like, which means you should be able to say, ooh, how is that gonna work? Because it's a snippet, how can I get the line number of who called us? Because what I want to do is to say this and have assert message be an expression, and it will be a message, or this should be format string, and then this. So just like print, we already have a print function that does this. Right, you pass it a format string and all your parameters. I want assert messages to be able to do that, to just piggyback off of print. I just need to make snippets that are typed, that can be typed. Let's put that on the to-do, because that is a really good... You just need to have typed parameters for snippets, and this will just work. Because then this snippet, so forget this function, this snippet can still be inserted into the tree as normal, but this we can say has to be a short string, and we can do this, right? Oop, sorry. We can do that, and then off we go. Then in here, right here, the message in this case, so we'll call this format string. Here, let's do this. Let me undo this and make a copy of it for what we want to do. To do, let snippets take named and take typed parameters, including any and ellipses. This will enable us to make print-like asserts, as well as just being a cool, powerful feature. See the to-do in Linux platform DB. We want to support print-like asserts, but we need to support snippets that can look like this. So, expression can be whatever, right? Well, no, expression has to come out to a B32, right? Even if it's a pointer, a B32 is just... Do I have B64? Is that a thing that I have? I don't. Okay, maybe we just do that. That's fine. I think that's fine. Because these could be addresses as well, and if an address is 0, it comes out to false, so that's fine. The format should be a short string. Or wait, how are we doing prints right now? Prints are actually, no, they're short strings. That's fine. And any there. And what we want to do here, so because they're snippets, these will still work. It'll still insert into the tree, but here, the dynamics, do we have, what does this take? Do we have a write output that takes dynamic strings? Oh no, we don't have to. We can say dynamic string, message is format string. It will take the format and the parameters, and then we write output. The message is data, and the message is length. Done. So the only thing that needs to happen to support this is we need typed parameters for snippets. Which we do not have right now. So why does that do that sometimes? I want you to, for coder can be very opinionated sometimes in a way I don't like, but that's fine. Okay, does that actually still work? We hit insert, great, awesome. We can leave that to do there. Any questions about what we just did just now? I think that's the first thing on my to-do that I wanted to get done. Which, let me see if that's true. Solidify, stringify. Yep, we're good there. Cool. So the next thing is just all this to-do cleanup. And there's a lot of to-dos. So I will be right back for just a moment. While I'm gone, it'll only be like a couple minutes. If anyone has any questions, definitely throw them in the chat and I will answer them when I get back. Thanks so much for watching, everybody. This is fun. Be right back. Oh no, I forgot to unmute. I apologize. Thank you. Someone told me off stream. Oh no. Well, okay. All I was saying is we're gonna start taking these one at a time. And wait, is that? No. Okay. Anyway, this currently breaks because args is a char star star, right? It's a character array. It's an array of character pointers. So if I just print out args, that's obviously not gonna work. So I don't know if we even want to be able to print that out. That might not even be a bug. If I say like U8 though, oops, we can't cast that way. Okay, that might actually not be a bug. We can't print out args like that because we don't know how many there are. So if we wanted to print out args, we would just say this. Right? Then you would say args index. And that does work. Or it should. Oh. Well, have them be the right thing. Wait, /in. Is there really only one parameter to this? Oh, I guess so. We aren't passing any parameters. Duh. Oh, that shouldn't be showing nothing. Why don't we see that? Okay, that is it. Is this causing that to not work? No. Okay, why is that not working? Let's look at that. Num args. So there's that. Print int. Yeah, why is that not showing up? Okay, that works. It's when it's by itself. What? What if there's a space? Oh no. Why does that happen? What if it's this? Okay, I broke numbers by themselves. That's not great. Weird. So there, it's an S64 5. And if we go here, we have a print that takes an S64. And I go to format string, that takes an S64. Weird. Let's step through it and see why. We need to change this to be not metagen anymore. We need to debug the actual program now. And stop here. Okay. Oh, I'm still not inputting tabs here. Let's put a to-do for that, shall we? Put that in code gen. No, let's put that over here. Put tabs in the chunk files. We didn't realize we weren't because forcoder indents for us. Okay. Step in. Don't care. Step in. Step in. Don't care. Step in. Okay. Format string. Num any params is 1 in this case. We make it cursor. Create a string builder. And the first format specifier should be at index 0. Which it is. So. ToString ellipse arg0. There it is. There's our string. It's a 5. Size 1, length 1. We append it to the builder. So builder, num strings is 1. And the head. Ooh. We didn't copy the number over. Why? Arg string. Oh, we lost it. Hold on. We just had it and we lost it. Why? We literally just had it, didn't we? There's arg string. It's got a 5. Let's go into append string. So, the string is a 5. We're going to use the builder's arena. Append new string builder node. That's fine. That's fine. So, this node is going to have on it this... We lost it again. We lost it somewhere in there. So here we have it. Or wait, where are we? Here we have it. Push type. Arena to use. Oh, this says its place is 0. Why? It's like it hasn't moved forward. So yeah, this is just overriding it immediately. Why is that? When we call format string, create a string builder in the temp arena. So the arena's temp space. Wait, where are we? Let's look at the temp arena. Its place is 0. That doesn't make any sense. Oh, okay. So that it actually does so far, because we don't allocate anything there. We just create a new string builder and point it to the arena. Here, though, we call ToString, and we should allocate a dynamic string on the arena, whose value is 5. Int to string. There it is. Length of 1. We allocate a dynamic string, whose length should be 1. So result.size should be 1. Okay, this is 1 off. That shouldn't be 1 off. My line directives are off for some reason. And then we push it. The place did not move though. Interesting. Push size. So the arena here. Arena place. Size in this case is 1. So result is arena place. We return where we were. And then place should plus equal. Okay, place did not move. Why? Let's do that. Let's try this. Just to verify. We're not moving. Size is 1. Huh? Am I crazy? What is happening? Stop shaking. That is really weird. What if I do plus equals 10 just arbitrarily? We segfault, which is fine. I just want to see what this does. We still don't move. Why are we not moving our place? What is happening? How is that even possible? That is really confusing me. It's like this is just not doing anything. Is there a reason I'm using place and not size? Like keeping track of the used space? Like, is there a reason to do that? I'm just gonna see what happens if I replace this. What about that? So we still don't see anything, but this arena now used as 0. We haven't used anything yet, which makes sense. So the result should be right at the start of the array. Or yeah. Then used should plus equal 1. Dude. how is that possible? Like, actually. Like, for real. Genuinely, what is happening? Let's go back to what we were doing with place, because that definitely didn't matter. Oh. Hey. This probably has something to do with that. I didn't put this back to where we were. What were we? We were at like 2 megs, I think, for... Let's look real quick. Yeah, we were at 2 megs for the scratch space. I don't know why that wasn't making a more obvious error and why it was working with other things. I think it's because our arena ring buffer stuff is still so strange and not how it should be. So that's dumb. That was a waste of time. Whatever. Okay, that works now. So I was doing, what was I doing here? Num args. Okay, great. God, that was so stupid. So now if I do that, and if I go out and I say like hello world 55. There we go. We pass the arguments. Okay, that's fine. So that's fine. This doesn't need to work. Although, if we do just pass args, shouldn't we like print a pointer or something? Because like this is trying to call out to the care star version. And I don't really know why. Because what did it generate? Right, it generated a care star version. Supposed to be fixing to-dos, but I want the like low-hanging fruit first. So print so let's have get pointer, get info type pointer. Oh. Right. So in this case, unable to resolve type for parameter get type info pointer. That's not what I wanted. Oh, we're generating these. So let's go to the metaprogram. Type info pointer. Where are we generating this at? Here. Okay, let's go to the chunk. Get type info point. Oh, these are. Oh, right. So, of course we can't get what this is. It's because, once again, I'm introducing macros here, which maybe I shouldn't be. So... Oh, but we can't concatenate names. That's another thing we can't do in snippets yet. So, currently the way this macro is working is, right, see here? It's type info underscore whatever you passed us. let's do a we should make a concat directive for snippets to allow you to do the macro thing like define so we're gonna say get type info type info type. This shouldn't be too hard. Then we can get back to supporting this below. The reason it fails is because the metaprogram is outputting a macro for this. When we need to stop making macros altogether and just use a snippet. Okay, so that has a to do better error message for this. Of course it can't resolve X. X doesn't exist. Unable to resolve type for parameter X. Okay, right, X doesn't exist. So, reported by the metaprogram. So let's go to the resolve type for parameter. So, where are we doing this at? This is in get param type, param node. If we have a decal node, right. If a decaref doesn't have a decal node, it means we failed to connect it to something. This just needs a better error message. Unable to resolve the decal name. Are you sure it is defined? Unable to resolve X. Parameter X. That's better. Okay. Should I generate type infos for function pointers in your program? So I'm thinking this is for like, we generate a type info for all this stuff. So like you can see here, type info underscore platform API. So I'll just copy this over so you can see this. So here's a platform API. It's got some pointers in it. It's just a struct, right? That has a bunch of functions in it and some data like temporary memory and stuff. It's a memory arena. We generate these type infos so you can look at runtime. You can examine your types. It's like introspection for your types. And in fact, let's just take a look at what that looks like. Type info, where are we? Struct type info. So here we go. A type info is just the name. So in this case, it's platform API. Num members, which are how many members it has. Type info pointers. So for every one of these types, so like a memory arena, it has its own type info. So for that member, it needs to point to its type info. And just if you want to iterate over their names and you don't care about going to their type info, I'm including an array of member names. I really don't think I should have to do that because you can just redirect. You're already looping over num members, so all you have to do is say members that and get their name. I don't know why I'm doing this. Is there a reason for this? That's weird. I don't know why I'm doing that. I feel like you shouldn't have to do that. That seems like an extra level of, we're just making type infos bigger for seemingly no reason. I'm gonna make the executive decision right now to remove that. That's not where I do it. We do this in the metaprogram. Member names. Each member should contain more info about what kind of member it is. Function pointer, array, constructor. Yeah, I don't know why I'm doing that. Too many initialize. Oh, so now the initializers need to change. So, right. So when we do that, not only do we generate the struct, we then generate a version of it for every struct in your program. So like all the base types, like U8 gets one, U16, all those get one. And then, so if I go to the platform API, so here's one for your platform API to show you that struct, right? So this struct has a bunch of function pointers in it and a memory arena. So platform API, it has one member in it. It's a memory arena. And then again, I'm storing the names. I probably don't have to. So I'm taking that out. So here, where are we doing that at? Generate type infos for our basic types, which are these up here. It's the name, the num members, and then the members, right? Name, num members, members. So that's fine. Where do we do it for the structs? Here. For each member's name. I just don't want to do this at all. Why do this? Okay. So there we go. Type info no longer has member names in it. And none of these are generating them. So, for example, here's the platform API that we were just looking at. So this to do here, should I generate type infos for function pointers? As you can see, this platform API struct has a whole bunch of function pointers in it, and we don't capture that in its type info at all. In fact, we don't even count function pointers as being members of the type info. And I have another to do here that even says, each member should contain more info about what kind of member it is. Right now, these member infos are just pointers to other type infos. From the base type info, you can't really tell much about these members. I feel like type info needs to have another thing on it that lets you know, hey, this is an array, this is a function pointer, this is specifically a constructor, right? Stuff like that. So that's what this to do is for. And I think we can just bake that into the type info. I don't think we need to add more to this struct. Well, we are adding more to the struct, but I mean, it'll be baked into this. So I think that's fine. The answer is yes. Okay. So what is this? I actually think this through. Is this even a thing we have to support? I think it is. We already dropped string literals into the stringified result without the quotes. This is what I wrote yesterday. And we did this. So now let's look at this and see if this prints out correctly now that we did what we did today. Right, we don't expect this to work. Right? Oh, actually, yeah, we don't expect those things to work because those are really oddball things to be calling. But the rest of this is like, if you pass in a string, you should get the string back. We did that tonight, so that's fine. I think one of my other to-dos covered this already, but just in case. This doesn't work. It can't resolve. So integer storage, we already have that. So this and this, we're saying this doesn't resolve. Unable to resolve parameter ellipsis arg0. So why doesn't this resolve? We create an integer storage, small bucket, and then we print out small bucket dot data. Trying to understand what this is actually showing me here. So, let's go to the final really quick. Oh, we're not writing this to the file, right? We're stopping before then, so we can't actually go look at this. So this instantiates a small bucket, right? That's fine. So this instantiates one. So we can go look at that. We create a small bucket. Right, so we have one of these. So we should be able to say array count small bucket dot data. So why can't we? Let's go look. This is gonna be back to here. And we're gonna be in code gen, I think. Unable, are you sure it's defined? Ah. Wait. No, this is in the metaprogram. Hold on. We just made a change to this. This is in util, right? We just did this. So let's see. Because this doesn't have a decl node. It didn't find what it needed to find. Default metaprogram. So we run the default metaprogram to generate function templates. Here, we are. Here's our function call, right? The function call, we're calling out to a function called format string. And we're passing it. Oh, right, because we're in the print function. We're passing it format. And we're passing it ellipses arg0. Okay, so let's go look at. Well, actually, yeah, let's look at these. So the format string, we tied it back to the parameter, right? And the parameter is called format. It's a type short string. That's fine. But the second parameter, called ellipses arg0, we didn't tie it back to anything. And the question is why? Oh, wait a minute, because we haven't generated that yet. Is that why? Our first pass through here, we see this, and we go generate it. We see this, and we see that we have to generate this, but generating this and this is happening in the same pass. So this, I think that's what's happening. When I generate this, this needs to be able to point back to it, but we haven't even gotten here yet. I wonder if, at this point, if we try to resolve it, although wait, do we do that? Yeah, we cogen internal. When we do this, does it immediately get added to? Yeah, it immediately gets added to the. No. We add them at the end. So that's the problem, is we add these things after we run the metaprogram and we generate a bunch of stuff that's not generated in the actual AST until here. Here's where we stick them onto the AST. So output source node. So we run the default metaprogram on input, which is the AST, and we say if it's the first time. And output AST, where is that used? Here. Okay. Here's where we do that. So we have the output AST actually. We do have it at all times. So maybe we can do this actually. Although that's not going to work because if we hook it up to the output AST, I think we copy that over. We don't just point to it. Is that true? We append child. No. We actually don't copy it. We do keep the original node. So whatever we hook up here will stay hooked up. So these connections will still be valid throughout CodeGen, throughout metagen. So, let's. I'm still not confident this will work, but it's a little bit of a wacky end around, but we're gonna try it. So, post pass. What do we do on the post pass? We want connect types. We want to connect declrefs is what we want. So let's look at connect declrefs. This still doesn't fix the problem where we can't resolve macro calls. I think we're done with macro calls, honestly. So connect declrefs. We take the parser and we take the AST. So we want to connect Wait. We want to connect the param node here. Here's what we'll say. Let's rearrange this and say if this doesn't have, if this was not resolved, if this decl ref is unresolved, try to resolve it now. Just in case something has been generated in the output AST. The output AST is not copied when it's appended to the parser's AST, therefore these connections will still be valid throughout metagen. So I think that holds true for us. So if this is not true, we need to try to resolve it. And afterwards we can say if we did resolve it, cool, otherwise we say we can't. We just say we can't do it. So now, what are we trying to resolve it with? We're trying to say oh, the problem is this function does not let us look up an arbitrary tree. It looks up the current tree. Crap. The problem is this function, you give it an AST and it assumes it's already stuck in the tree of the whole program, and it can look up the tree to resolve it. It can't just look up into some arbitrary other tree. So what I want to do is give it this node and have it look up in this AST. So really what we want to say here is connect decl refs needs to take the decl ref AST, or like the this is the AST that you are, so connect decl refs connects the decl refs in the target AST by looking upwards starting at we'll call this other one lookup AST. If you omit the second AST, we assume they are the same. So we can say you don't have to give us that. Change all of these to, well, let's not do that yet. Let's say if not, lookup AST equals target AST. So if the target AST is a snippet, we skip it. If it's a function call, we go over all of our parameters first, and then our name. Same thing here, but now we say so let's just make sure we didn't break anything there. Okay, we're still in the same place. So now we say, when we connect declarefs, we're going to pass them both. We're always going to pass up the lookup AST in all of these cases. Right? And then, so actually for now, let's remove this just to make sure that we're still working. Let's remove this thing and uncomment out all this stuff. We have too many of those. Okay, so we still work there entirely. So far we haven't broken anything. And then find and connect declaref, right? So find and connect declaref, given a parser and a certain node. Declaref match upwards, right? So this is where we look upwards. Yeah. So here we need to take the node and the AST to search. This will also take the AST to search. And so will this. So now when we look upwards, this will take the AST to search. And now, when we search an AST for the... We're now going to search the AST that we passed in. Hold on, this is actually looking up from the declaref. Right, okay, hold on. So we're gonna say parent is the AST to search, right? And we'll keep going up there. Yeah, and then here, we'll also pass a 0. No, we'll just say if not AST to search, we're gonna search in this node's parent. That probably definitely broke. Find and connect declaref. So this we will say is 0. Yeah, okay, we just broke a lot of things there because that was very haphazard the way I did that. What we want to say, let's just look at this. We connect all our declarefs. If we don't have one to look up in, we just look at ours. And then we call this. Okay, well we're at least compiling now. This was old debug code. Okay. So in here, if we didn't pass an AST to search through, we just look up our parent and go up, right? Which shouldn't break what we're already doing. Actually, to make this a little more like what we were already doing, we'll say If AST to search equals our equals ourselves, we will look up our parent. So what did we do here? So by default, if we don't pass anything, it's just the same thing. Which... Wait, hold on. Let's not do that actually. We're gonna pass it nothing if we don't. And if we got nothing, then we search ourselves. Okay, we're back to that. If we didn't get anything, this, I'm just flailing at the wind now, so we're passing 0 to this. And if we weren't given anything, can we also pass 0 down? Okay. And if we were passed nothing, okay, I think that's what we want to do. Let's go back and have this work like it did originally if we just pass nothing down. I started from the wrong place. I started from the top down. I need to start at the very bottom of this stack before I do this. So we have the target AST. Okay, are we back to normal? This is arg. Okay. Okay, we're back to normal. So when we look for a match upwards, we want to pass a starting point. Starting point. And by default, it'll be nothing. If not starting point, then our starting point is just the decal ref. Right? And then this will be starting point. Will just be starting point. It'll just be the decal ref's parent. Right? So this should work exactly as it did before. Yes. Great. But now we can actually search now we can actually search up a different starting point. So down here, find and connect decal ref, we can say AST to search, and this will also equal 0. If not AST to search, then we will do something different here. Okay, so here we find a match upwards. We're going to pass it the AST that we're supposed to search through. And by default, it'll be nothing. So it'll just be, we can just pass 0 through. This should still work. Yep. See, this is why I should have started from this point and not the other way. But now, here, you should be able to pass a lookup AST. We assume you're just looking upwards from target AST. So if not, look up AST. Look up AST. Well, whatever. We can just say this is 0 in that case. And we pass. So make sure that still works. Now we just pass. Look up AST to all these things. Right? Do we still work? Yes. But now we should be able to resolve this by, let's try to connect declarefs. We'll pass it the global parser. And we will just pass param node, but we're going to look it up in the output AST. And we have to do the C thing for declaring this stuff. Wait, I have to do it in both places? That's not true. Hold on, what did I do here? Oh, I just didn't save it. Okay, so that still works. Now, do we now resolve this? That's what we were trying to do this whole time. No. But now we have something to step through here to see why. This declaref is unresolved, try to resolve it. So we tried to look it up in the output AST. So let's just see if that does what we think it's doing now. Here. So what are we trying to find? Declaref called ellipses arg0. So this is the only place this happens right now. If we go in here, it's not a snippet. It's not a function call. So for each node of the declaref, it's just us. We don't have... Wait. What? It's not a function call. Wait. What? It doesn't have any children. Do our children first. This is wrong. Did I screw something up here? What did I do there? Oh, I'm only connecting the declarefs of the children, not of the thing that we passed in. So do our children's children first, then our child, then do us. If we're a declaref. If target AST type is a expression declaref, then connect us to, please. Okay, so let's see what we do now. So we are a declaref, so connect us, please. we are a declref. We do not have a node because we aren't connected. Find declref match upward, and the AST we're searching is, this should be the chunk file, which it is. It's the secondary chunk, which should have wait a minute. No, it's not gonna have what we're looking for. This thing exists in the primary chunk. But wait, if it exists in the primary chunk, then it exists in the AST, does it not? Hold on. Global parser AST. We'll do it. How will we just do it in both? We'll try it in either one. I must not be understanding something about this, because we're looking at the entire AST here. And we search the AST. So we're going to search this entire thing. Oh, wait, upwards. Hold on. Okay, wait, that's not actually doing what I thought it was doing. Let me undo this. This is getting confusing now because this is a part of the parser I haven't touched in a while, so okay, so this looks upwards over and over and over. Search AST for declref type match. So we search through, otherwise we find type match for name upward. Which is here. While parent, we search the AST for the decl name. So here's where we actually go through all of the things. Let me actually go back and make sure that we are looking through the right thing. That might have got lost at some point up the tree of this call stack. Because it looked like we never actually got to the point where we were searching the AST, like ever. And I feel like as long as we search for it in both the output AST and the global parser at large, we should find it. I feel like we should absolutely find it. So, not there, we already determined. It should be in here though. upwards. So now our starting point is what? It's the root of the whole AST. We have it. Search for it. Find it upwards. Search for it. Here we go. And what are we looking for? We're looking for not child. Hold on. What am I looking for? We're looking for ellipses arg0 in the function call. And this should be print. Where are we? Oh, format string, because we're inside of a print, which calls format string. We're not going to find it there. So now we're looking in... Well, we're not going to find it anywhere in this one, so that's fine. We didn't find it, so now we go up one. And now we're looking at output. We're not going to find it. We're looking at the compound statement inside of the function print. Right, so we're looking... We were in format string, now we're in print. We're still looking for it. We're going upwards. Now we're in the whole source file. We're looking in primary chunk. But wait, what are we looking for? For name. Ellipses arg0. We should find that in print, should we not? Okay, hold on. I feel like this is where I'm getting confused. This has gotten very complicated to do this one. So our starting point is the root of the tree, because we passed it the root to look for. Okay, why did we lose the root at that point? We're saying, look for this in this. So find and connect, look for this, and hook it up looking in this. And this is the root. So, look for this declref in the root. Search AST for declref type match. The parent is the root, and we're looking for our declref. Still at this point, this should be the ellipses arg0, which it is. So, we are searching in the root for ellipses arg0, right? Oh. No, now we stop looking. Why did we stop using the AST here? Now we're starting back from the declref. But we gave you one to search for. We gave you a lookup one. Oh. Because right here, we don't pass it down. No, we do. The parent... Okay. Part of me feels like these are just named poorly, because when I was doing it initially, I was starting from just the node and going upwards, but we're doing some other weird stuff now where I feel like that's no longer true. I think I'm gonna have to look at that when I am not so when I feel like I'm so out of it. So let's add this to do here. If this, can we try to resolve it now? Just in case something has been generated in output AST, has been generated by a call, has been generated. Although wait, this is when we're running the metaprogram. I'm butting up against the limits of my metaprogramming like knowledge and experience. Also, that scared the crap out of me. People still shooting off fireworks. Let's go back on this stuff because I don't think this makes sense to do what we were doing. I don't even think it was working the way I thought it was working. So that's fine. Okay, so let's go back here and say this. It can't resolve. I added a to-do to get param type that explains what we might be able to do to resolve this situation. I'm not sure if it's correct or even has the right assumptions. We'll need to think harder. Basically, the call to instantiate small bucket causes an integer storage 128 to be generated, causes a struct definition for this to be generated. But we have when we connect that up, do we not? That actually might be the problem. Struct templates. When we do this, when we generate the struct template, add struct decal to program. Add struct decal to program. Do we go through and okay, so when we generate functions, like if you call a function that doesn't exist yet and it goes and generates it, we go through and update all the function calls that call to it and point it to the right place. We must not be doing that here. Or obviously we're not doing that here. When we create a new struct decal, anything any decal ref that should be based off that struct needs to be hooked up at that time, I think. And that's not happening. So, but I think that would solve the issue, like kind of entirely. So when does that happen? The parser parses this whole thing. It sees this. It parses that as a struct template call. Although, wait, before we even get to the metaprogram, this should be hooked up to this. And we're saying it's not, right? What if I do this? That works. This is getting hooked up to this. But if I embed this directly... Okay. I might have been confused about what the actual problem was here. It's not like it can't figure out what this is. It does figure out what this is. So hold on, let's get param type. Let's undo this to do, because I actually don't even think this is accurate anymore. I don't even have it to do in there. It can't resolve in the second print. So let's do both of them. What? Okay. So, that tells me everything I need to know. The problem here is not... This is getting resolved to an int just fine. And as long as there's a print function that takes an int before this, I'm treating that as an error, so we actually work just fine as long as there is a print function that takes an int. But if there's not, it's this thing's job to generate that print function that takes an int. And for whatever reason, it can't determine that this should be an int. And I'm wondering, is array count a macro? No, it's a snippet. Okay, it's a snippet that does this. Okay, hold on. What does that look like in the tree? What does this look like? Print 55. Okay. Small bucket is an integer storage 128. That's weird. That needs to go away. I won't worry about that right now, though. Then we call print with /n. It's a binary. We call size of on dot data, and we divide it by size of dot data sub 0. Right? Size of dot data, size of dot data, sub 0. And it can't determine what? It can't determine. So small bucket is pointed to the right place, which is here. So it is pointing to it. And this is pointing to the correct member. So what can't it determine here? Okay, we're close though. So this is we're very close. So what is size of we're saying that's a keyword. Is that because it doesn't know? Expression keyword is size of. The metaprogram might not know that size of should be treated as an integer. Let's see. Util. Do we have a keyword in here? No. But this is not a keyword. Yes, it is. It does eventually go down to keyword. So, keyword. Expression keyword. So, let's just see in this case. I just want to see if this works. Report error and exit. We don't do this yet. Do we hit that? No. We don't. Even though if we hit a binary operator, we get the param type of its children, and the param type of this print is a binary operator. Oh, it's a function call. Hold on. Function call. Get param type of its first child, which is a keyword. We do hit it though, because when we call get param type again on that. Let's break there. Binary. Let's break here. Actually, let's break on the divide. Here. What? We don't even hit that? Am I losing it? How do we not hit that? All right. Let's go to function templates. We already have a breakpoint in here because this is such a common thing to debug. Stop printing out the tree. Wait. Damn it, hold on. I didn't realize that I didn't have... Okay, that still doesn't matter, but that's fine. Okay. We want to go here, and we want to look for print. So we already have a breakpoint ready thing there in metaprogram. Okay, here we go. We're going to break right here. So we actually have two of them for whatever reason. This should be online 133, which we're looking at node 133. Okay, so it's not inside a function template. It's not part of a snippet. It does not have a... Okay, so we're going to generate function templates on the function call. Generate function templates. Oh, that's if... Okay, we don't have to do that. That is for if we call a function and one of its parameters is also a function call that needs generated, we have to do that first. I should put a comment there explaining that, but... Okay. We search for a function template that matches this name. And, okay, that's what this one is for. Let's put one there specifically. And we're looking for a function call whose line number is 133. Okay. So, verify the parameters match. So this function call has 3 children. This should be print, which it is. This should be the %in. We already know it is, so we don't have to check, but just to be thorough, there's %in. Now, this binary operator has 2 children, and they're both function calls. They should be function calls to size of, right? Which it is. So, do the param types match? The call arg is a literal string, because this is the first parameter. We don't care about this one. Oh, that's the required ones. We only have one required one. That's fine. Because we are an ellipsed function, we're matching the ellipseed parameter. So the number of extra parameters should be 1, which is just the one we're trying to match right now. Here we go. Corresponding param index. The param type of this is a U32 function called children. Wait, is this the one we're looking for? Did it already just work? Call children corresponding param index. Ah, stop Visual Studio. Binary operator. It got it. It said U32. Okay, how though? That's what I want to know. How did it do that? How did it know? So the param node here is a binary operator. And it should be the divide. Which it is. Yes. It's a function call. Keyword. It just returns result. Oh, it has none. There we go. That's why. Ellipses arg0 has no type. So it is what I thought it was. So wait, why didn't that show up then? We don't do this yet. Oh, is it? It's because I had this uncommented. I still had this uncommented, didn't I? Damn it. Okay. If it's a keyword, we are going to say we do not understand. Here, we'll do this. So if we'll switch on. No, we'll say if. How are keywords stored? Keywords are stored with just the name. So, keyword is, well, no, we don't even need to do that. We can just say if param node info expression keyword name is, and actually we're going to do this a lot, so we will do this. Keyword is make cursor this. Okay. Keyword is size of, else, no matter if we hit nothing else, we do not understand. We'll do this. We do not understand the keyword yet. Result equals a U64. Ha ha ha, we work now. That's all that was. I was missing one of my expressions in the param resolution. Great. Okay. That's awesome. Okay. And now we future-proof this as well. If we ever hit any other keywords that we're not understanding, we will now see a message that tells us exactly what's wrong. So that's great. Is this ever getting hit? No. Okay, we need to do this as well. This will also help us catch stuff. Unhandled node type in get param type. I don't remember if report error and exit tells you the function. No, it tells you where in the program, but not the function it came from. Okay. And actually, let's just say unhandled node type in get. You know what? We'll just keep it verbose. That's fine. All right. I'm really glad I got that fixed. So that took a long time, though. I was chasing totally irrelevant things. So we got there eventually though, so that's fine. You know, it happens. So, we currently hard expect identifiers. Let's do this next. So here's one problem. If you've ever seen some of these other languages, or like I took specific inspiration from Jonathan Blow's language with these tags, you can tag pretty much any decal. And then all a tag doesn't show up in your actual code. A tag is something that the metaprogram can query on decals. Decals, it can just look to see if they've been tagged with anything. So you can use that to communicate information to the metaprogram to do stuff with. So you could say this is a hidden or whatever. So if you have code if you have a metaprogram that like serializes your data, you can tag members here and say, oh, this is hidden, so don't serialize it, right? Stuff like that. One really cool thing he does is tags members with a version number. So you might tag the whole struct as being, or you might tag a file format that you're doing for a game, like a save file. You might have like a version number, right? You might have a version number here. And you can tag all of the, say as you've been building your game, every version of this struct that might be changing over time. To make that backwards compatible is kind of frustrating. It ends up with a lot of duplicated code. Well, you can tag, right, when certain members got introduced to this struct, right? So say we're on version 2 of this. This count got added in version 2. What's nice about that is you can have a metaprogram generate serialization code that knows what the current version number is, and if it was handed one of these, that if it's handed a save file, for example, that is an older version, it knows, okay, when I load all of its integer storages, they are not going to have this member in it, and it can handle that properly for you. So you just have to make sure you're tagging these things with versions, and you're good. So there's an example use case of tags. But say in the future we're on 3, and we have another thing here that we added in version 3. But say we removed count as well, and actually let's say we're at version 4, we can say that this is only valid between versions 2 and 3, right? Say that we have that as a tag. My tag system does not allow for this right now. In fact, it will complain. Or it'll just freeze forever. Really? That's weird. Is it because of this? Oh, for one, we're printing out tags still. We shouldn't be doing that. Yeah, let's not be printing out tags. Maybe that's why, specifically, because we're printing them out. No, we're just choking on those? Okay, we shouldn't be choking on those, but the reason it's failing is because it is expecting these tags to be identifiers. And they can be comma separated too, so I can say like this is v4. Like you could... Ooh. Maybe I don't have to support this, because you could just do this. No. You can't? What? I thought for sure... Oh, wait. It did... Oh. Is it because of semicolons there? Okay, I am confused. I thought these were working way better than they apparently are. Really? Okay. I could have sworn these were working. If I print these out again. It has no tags. Although, wait. Data has a tag. Okay, tags are broken, actually. I don't know how that happened, but tags are broken. Really? Let's print out the AST again real quick. Is it because this is a struct template? Is that why? Like if I tag main. No, tags are just broken. How did that how did that happen? When did that happen? Let me go back to what I had before, because that should absolutely be working. Anyway, the reason that that other thing I said wasn't working is because it's expecting an identifier here, and identifiers can't have minus signs in them. Yeah, okay, tags are broken. Let's figure out what happened. Parser tag. Parse potential tags. Let's just break there, shall we? Parser parse potential tags. Okay. So where are we? Next is online 155. That's this. Okay. We skip it. We expect. Wait. Next is token tag. We skip it. Should be a colon followed by an identifier, which there is. Create a copy of the parser. Num tags is 1. Peek the token. The token is an identifier called v1. We know how many. Oh, we counted how many tags. There was just 1. So we say there's num tags 1. Push array. Get token text. So the parent node's tags. Wait, we're grabbing the semicolon. We're skipping one too many things here. That's why. The tags are working, but it's grabbing the semicolon. Wait. Expect token. The current one is a tag. Oh, this is just totally wrong. This whole logic is totally wrong. I don't know when that happened. Okay, we look at the next token. If it's not a, if it doesn't exist or it's not a type tag, we just leave. Otherwise, we skip it and we have to grab the next thing. How did this happen? Okay, we grab the next thing. So the next thing should be a colon followed by an identifier. So we make sure it's a colon, skip to the next one, make sure an identifier. Yes. Okay, we're still not out of the woods yet, but that was definitely broken. So next is a colon. It should be. Skip it. Identifier, it should be. Boom. Oh. That's why we added this temporary copy. But we need to do that. We were skipping. That needed to be temp right there. I think that's literally the only bug. Temp copy. Yes, okay. We skip over advance, skip all semicolons. So true, is that why? No. Okay, let's step through this again now that we know this is working. So let's recompile. And okay. Skip over all those. We make a copy of the parser. We skip past, and the copy of the parser is now sitting at the identifier. So we count it and skip it. So now we're on the semicolon. It's not a comma. So we go back here. And parent node tags v1. There we go. So it got it. Okay. Okay, and then we need it. Okay. Once we get them, parse potential tags. If it's a comma, we skip it. Otherwise, don't. Blah 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 blah. Then, if peak token parser type is a token semicolon, we can skip it. And actually, let's just skip all of them if they added multiple of them. Hey, look. Okay, we're back. That is ridiculous. I don't know how that got in there like that. So if we do this, though, now we should get the error that I was expecting to see, where we don't understand the minus there, because this needs to be an identifier. And I should be able to do this as well with commas. So now we're saying this has two tags, v1 and v2. There, so v1, v2, okay. That was just a bug that got in there at some point. I don't know how that happened. Okay, and now that I think about it, maybe this is okay that these are just identifiers, because sure, you can't do this, right? But you could just as easily say this was in v2, v3, and v5, right? You can basically do whatever you want there as long as they're an identifier. And that makes so much about parsing it a lot easier, so I think I'm just going to leave it that way. And if you wanted to do something fancy, you could do like versions, like, I don't know, 1 through 5 or 4 or whatever. Like you can write whatever tag you want, and then your metaprogram can parse it however you want. So I think that's probably fine. I'm okay with that. Support this next. What do I not support here? Oh, struct templates don't support any of. Is that what this is? Yeah. Okay, we can definitely do that. It's getting late though, so I have a feeling I will start tackling more of these next time. This should be dependent on short string, but it's not. We consider this a pointer depth of 1, and thus don't think we need to depend on it. We need to recognize cases of fixed size arrays and treat them as hard dependencies. Once we track arrays and such in the tree properly, querying that will be a lot easier. Okay. So this struct has a array of 8 strings in it, short strings. So this should depend on short string. And it looks like it does. So I think this is an old to do, because struct short string is here, and we're saying another bug depends on it. So what if we put this above the depend? Does it still work? Yes, so that is actually fixed. That is not even irrelevant to do. You love to see that. Don't just crash endless loop on these. Definitely happens if this is the last thing in the file. Okay, so if it's the last thing in the file, this just crashes apparently. Okay, that crashes. And this is an endless loop. No, that crashes too. Okay. Oh, is that because it's not semicolon? Yeah, if it's semicolon, it's an infinite loop. So we don't handle the end of the file properly. That seems like very low-hanging fruit. Don't need this. Okay. So there's still a lot of to-dos here. Putting tabs in the chunk files, I think. So if I open, how have I never done this? If I open this in Emacs, yeah, these just aren't indented. So I can, I think, do that pretty easily. So code gen, chunk. Oh, it's when we output the file, right? Generate source file for chunk. So for each child node, okay, I think we're gonna need logic in here. So we're gonna have to say for each child node, if it's a I think we can just use some kind of state machine for this and just be like, so indent or depth is 0 to start, and we'll just say whenever we whenever we're going to output a node, we say for depth ID is 0, depth ID is less than depth. Okay, what we will do, oops, is we'll just append a 1, 2, 3, 4 for every time we are there. And what we'll say is if so if we're going through the tree, this actually isn't going to work here. This function needs to be aware. That's a lot trickier, actually. And that is so tricky that I don't feel like thinking about it tonight. I think this will be pretty tricky because append node as string needs to know about this. Depending on the node you're outputting, and if you're doing it to a chunk file, it needs, depend on the type of node you're outputting, and if you're doing it to a chunk file, it needs to insert a tab, an indent beforehand, but it also needs to accumulate indentations based on the depth. Sounds annoying, not necessarily too tricky. Pretty annoying, let's say. So that's fine. Ring buffer, that's going to be when we go to the platform layer. That's not a to-do for us to do right now. So let's say to-do meta, right? This can be to-do meta. So let's do this. Let's say to-do meta. Wait, I screwed that up. Okay. To do meta. To do meta. 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 And meta. Okay. Oops. Okay. That's fine. We can come back to these. This is also meta. I forgot about this one up here. This will actually be really nice. This is more about like build system stuff, but this is also for the platform layer stuff. We don't have to worry about that right now. It is getting very cold in here. This is for platform layer. Okay. Well, I didn't really knock out that many to-dos. I did a couple of annoying ones, and we did get stringification working really well. So I'll call that a success for tonight. Thanks for watching, everybody. Hopefully people kind of understand what's going on here if you're watching. I can get into the weeds once I'm debugging certain problems like this, but yeah, thanks so much for watching. I will definitely be streaming more in the future. We're getting really close to the point where I can be done iterating on the metaprogramming layer, and we can just get to the actual library I want to build with it, which will be the platform layers for the different operating systems, making windows, interfacing with graphics APIs, just like the whole thing. We're going to be building out the actual library using all of this cool metaprogramming stuff. So that's where the future takes us. Long stream tonight. Thanks everybody for watching if you stuck with it. And yeah, everybody have a good evening, afternoon, whatever time it is for you. Take it easy.